Hello children, happy to meet you all again with yet another topic on metallurgy, extraction of aluminium. Aluminium is one of the important metals. See, it's used for making various products starting from kitchen utensils to the mobile phones and laptops, the packing material and so on. It's one of the important metal in our daily life. You could now see so many things there, right? Now you can see what is it? Aeroplane. It is one of the important use of the alloy of aluminium. Here you can see the packing material is made of aluminium foil. Aluminium and its alloys finds wide use in the automotive industries. You can see that many spare parts are made of aluminium. Now let us understand its position in the periodic table. Where it is located, you can see that it is found in the third period and in the 13th group below boron. Its atomic number is 13 with a configuration of 283 and its atomic weight is 26.9. How abundantly it is available? It is found on the Earth's surface around 8.1%, most abundant next to oxygen and silicon. Source of aluminium: bauxite, cryolite, corundum. What is its chief ore? Bauxite. What is bauxite? Bauxite contains 30 to 60% of alumina along with silica, iron oxide and titanium oxide. This ore is found in the upper surface of the Earth's crust. 4 tons of bauxite on smelting gives 1 ton of aluminium. Now let us understand the steps involved in the extraction of aluminium. There are 2 steps. What are they? Chemical method followed by electrolytic reduction. What is the chemical method followed here? It's called as Bayer's process. Here the bauxite is converted into alumina. There are 2 steps in the Bayer's process, namely the formation of sodium aluminate and secondly aluminium hydroxide formation. Carl Joseph Bayer introduced this method. In this method, the ore is sent to the crusher where it is crushed into pieces and then followed by the digester where sodium hydroxide is treated with, which gives sodium aluminate. This sodium aluminate is filtered and then treated with water to form aluminium hydroxide. This aluminium hydroxide is then tried washed at a temperature of 1000 degrees Celsius to form the pure alumina. This alumina is then reduced by electrolytic refining method. Here there is a steel tank which has a carbon lining that acts as cathode and there is bunch of electrodes made of graphite act as anode. This method is called as Hall's refining. The temperature maintained in the tank is around 900 to 950 degrees Celsius and the electrolyte is pure alumina with molten cryolite and fluorspar. The function of the fluorspar is to reduce the fusion temperature of the electrolyte. In this electrolytic process, you can see the steel tank with the graphite lining. Also, you can see the bunch of rods. They are made of graphite acting as anode and this graphite lining acts as a cathode. When the current is allowed to flow through, the alumina which is taken as an electrolyte decomposes to form aluminium and oxygen. The oxygen gets liberated at the anode where the anode is made up of graphite. Oxygen combines with graphite to form carbon dioxide. The aluminium which is formed is in the molten form, flows down towards the bottom of the tank and it is collected at the cathode. The liberated oxygen reacts with the graphite anode to form carbon dioxide. So what is the overall reaction? Aluminium oxide gets reduced by electrolysis to form aluminium and oxygen. Now, some of the applications of aluminium. It's used as kitchen utensils, electric wires to manufacture airplanes and industrial machinery parts, and many more. Now, some of the properties of aluminium. We all know it's a silvery white metal. It's very light in nature with low density. It's very good in malleability and ductility. It's a good conductor of both heat and electricity. Now, some of the chemical properties. What happens when aluminium reacts with air? With oxygen, it forms aluminium oxide, and with nitrogen, it forms aluminium nitride. What happens when it is treated with water? It do not react. But with steam at high temperature, it forms aluminium oxide and hydrogen gas. Now, the very important property of aluminium is it's a very good reducing agent. When treated with iron oxide, it forms iron and oxidized to aluminium oxide. This is an important application which is used in welding the rails in the railway tracks. This is aluminothermite process. Now children, let me check how much you have understood. Find out what is this electrolytic cell is. Identify what is A, B, C, D, E and X and Y. If you are not able to, then watch the video again.